In this lesson, we're going to implement single sign-on using Keycloak's OpenID Connect authentication protocol with Grafana as our example application to illustrate how the OpenID Connect authentication flow works. So when a user accesses a service like Grafana, Kafka, Elasticsearch, doesn't really matter, but in this lesson, we're going to use Grafana as an example. They're going to be redirected to Keycloak for authentication. Upon a successful login, Keycloak issues both an access token, which grants permission to use Grafana or whatever service you're giving single sign-on, and an ID token, which contains the user's identity and role information. Grafana or whatever software uses the access token to decide if it should grant the user access to simply use the application. It also uses the payload from the identity token to be able to verify the identity of the user, who they are, and what kind of permissions they're allowed on the service. In Grafana, that's whether that person is an admin, editor, or viewer. This is what makes OpenID Connect very powerful. It extends on the traditional OAuth protocol by also providing identity information, not just simple user access. It enables services to not just authorize users, but know exactly who they are, so that the service knows what kind of roles and permissions they're allowed to have. This tutorial is completely hands-on. I'm going to provide you with all of the necessary configuration files, so let's just dive right into it. But before doing so, I just want to deliver a very quick message. If you find these DevOps tutorials helpful, consider subscribing to this channel for more DevOps and cloud native content. Also, if you're looking for a complete Kubernetes course that teaches the best practices for cloud native app development and deployment, check out my course by clicking the link inside the video description. Kubernetes is the cornerstone of modern cloud infrastructure, and my course covers it all. All right, back to our demo. To begin this tutorial, you need to download the project files, which I'm going to link you to right now. Inside of your video description, I've left you a link that you can use to access the GitHub repository. Go to it because it contains all of the starter code that we're going to use for this lesson. Clone the repository inside a directory of your choice. Doesn't really matter which one. I'm going to clone it inside of the following directory where I can easily access it and launch it inside of my favorite text editor. All right, spin up a new terminal session and let's begin. So the Docker file that you see over here contains a Docker Compose environment that's going to run an instance of Postgres, which will store all the data that we save into Keycloak. It's going to run Keycloak, of course, with credentials that we can use to access the Keycloak admin console. And it's going to run Grafana, which will rely on Keycloak for single sign-on capabilities. And inside of the following file, we're going to configure Grafana to implement single sign-on via Keycloak. Now, although this grafana.ini setup is specific to Grafana, the fundamentals that you'll learn in regards to the OpenID Connect authentication flow, you can scale to whatever application you want to give single sign-on to, whether that's Kafka, Elasticsearch, doesn't really matter, okay? Because the concept of a client secret, an access token, etc., all of these are the same regardless of which app you want to give single sign-on capabilities. Okay, so let's go ahead and start this demo by running Docker Compose up. That's going to start up Keycloak as well as the application, the client that relies on Keycloak for single sign-on. First, we need to cd into the Docker folder, then run Docker Compose up. All right, so while that's set up, the other thing I left for you inside of the README is a link that you can use to download Postman because we're going to be using that for testing and troubleshooting. So download Postman. If you already have it downloaded, please make sure that you open it. All right, because I left you with a Postman collections file that we can use to make Postman requests against Keycloak so that we can troubleshoot as we go along. So that's going to be this file right here. Which I'm going to import right now. Alrighty then. So we can use this to make requests against our Keycloak server, which is running on localhost 8080. And now here's the thing. This single sign-on tutorial, I've already recorded it, but in a Kubernetes environment. Because nothing changes, I'm not going to re-record the tutorial. The only things you'll notice that are different is that instead of localhost 8080, in the recording I'm about to play, it's going to say localhost 30,080 because that's just how it's exposed in Kubernetes. Make sure to keep your port, of course, because that's where your app is running. The other thing is whenever I configure things inside of my values.yaml file, you're going to configure inside of your grafana.ini file. Okay? For the most part, all the fields are identical. You just need to change these fields according to whatever I change in my Kubernetes YAML file. Okay? So I'll go ahead and play the recording right now. Please bear these considerations in mind, and let's begin. I provided you with a diagram that illustrates how the authentication flow is going to work. So, regardless of which app you're granting single sign-on capabilities, whether that's Grafana, Kafka, or Elasticsearch, whichever app relies on Keycloak for single sign-on, that would be deemed a Keycloak client. You yourself, the user who's trying to sign in to one of these applications, in this case Grafana, you would be deemed a user. So what we need to do in Keycloak is set up an authentication space that stores all of the users that need to sign in, what roles they would have inside of whatever application they're trying to sign into. Okay? Every client that you store in your Keycloak realm is going to have a client secret. Every user that you store in the Keycloak realm is going to have a username and password. Why? Because once we're done setting up all of the authentication components, now let's imagine that I'm inside of the Grafana homepage and I click the sign in with Keycloak button. What's going to happen is the client, in this case Grafana, is going to provide a client secret. Okay, that client secret needs to match what's inside of the Keycloak realm. If it is, then the authentication request is going to be deemed valid. Keycloak has verified that this is an official Keycloak client. All right, and the user who's trying to sign into that client, to that application, using Keycloak needs to provide valid Keycloak user credentials. If these are valid, then Keycloak will effectively allow that user to sign into the client, Grafana in this case. How does it do that? So upon a successful authentication request, tokens are issued. Two types of tokens. There is an access token and an ID token. An access token authorizes the user to gain access to the client's services. In this case, it would authorize me to access Grafana. The ID token that Keycloak gives the client tells the client who I am. And from there, the client can decide what roles to give me within its services. So in this case, whatever identity Grafana gets back from Keycloak, it can decide if I'm a Grafana admin, if I'm a Grafana viewer, or if I'm a Grafana editor. So this is where OpenID Connect goes a step further than typical OAuth, because a simple OAuth flow would simply grant the user with an access token to access the client's secret. But OpenID Connect goes even further in also telling the client our identity, giving it the ability to identify us, whereby the client can then decide what role we can have within whatever services it provides. And ultimately, all this is saying is when we have the right tokens issued, we're able to access whatever protected resource is being protected by the client. Okay, and that's pretty much it. So this is what we need, but uh, this is what we have. All right. If you're following from the Docker tutorial, then your grafana.ini file is going to have pretty much the same exact configuration. You just need to modify things according to whatever I do over here. And whatever kubectl commands that I write, Docker viewers, please feel free to ignore them. Okay. Anyways, now let's go ahead and access Grafana. So host 3000. And I can choose this sign in with Keycloak option because I've configured your Grafana installation to have this option, but it's obviously not going to work. We get a "we're sorry, page not found." Here is why. So Docker viewers, you should see localhost 8080. I'm using Kubernetes and my thing is deployed on this port. Okay. Anyways, the reason is it's trying to access a Keycloak realm called test realm, but that realm doesn't even exist. We haven't set up any of these authentication components. We haven't set up a client inside of Keycloak. So Grafana can't identify itself using this client ID. So none of these should work until we actually start setting some stuff up in Keycloak. All right. Now, Docker viewers, you should be able to access Keycloak like so by saying localhost, what was it, 8080 or 8000? You would know. Docker viewers, your username and password should be inside of your docker compose.yaml file. It's admin and admin password or something, but verify. So for my Kubernetes users, the credentials that you're going to use to log into your admin portal is admin and admin. Simple enough. So now the first thing that we need to do is set up a realm. I'm just going to create a new realm, call it Grafana. Create this realm. And we can already start making changes. So now that we've got our realm, Grafana, let's go ahead and make adjustment to our configuration file. So wherever it says test realm, change that to Grafana. All right. These URLs are unique, as I'll show you in Postman just a bit, because in this case, Grafana is going to be using them to access tokens, get user information, so on and so forth. All right, so test realm, change that to Grafana, Grafana. So now these should be fine. And so here you'll notice the authentication URL must be accessible from the user's browser, whereas the token URL and API URL are requests that are directly made between Grafana and Keycloak internally. Okay, so Docker viewers, this should reflect the Docker network where both your containers are running and be able to make internal calls between each other. But this begs the question, why does this one need to be accessible from the browser? Well, you'll remember that when we click that sign in with Keycloak button from the browser, we need to be redirected on the browser to the following endpoint where the authentication token can be retrieved, the access token, thereby allowing the user access into our Grafana service. Okay, so this needs to be accessible from the browser accordingly. So the realm we've got figured out. The next thing we got to change is the following. So now let's go ahead and create a new client. The client in this case, I'm also going to call Grafana because because Grafana in this case is a client of Keycloak requesting single sign-on capabilities. All right, we're going to click next. Standard flow, yep, works for me. the root URL is where your client is running. In this case, localhost 3000. All right, so that should work fine. Anyways, I got sidetracked. Valid redirect URIs is interesting, and that's where Keycloak is basically allowed. That's where we can allow Keycloak to send users after logging in. I don't remember specifically where Grafana expects users to be sent after a successful authentication. So what I'm going to do is just copy the URL, put an asterisk to say allow users to be sent on all Grafana paths, wherever Grafana decides to send them after Keycloak does the authentication. Okay, do the same thing for logging out. Web origins is usually the same thing as the root URL, because that's just for to accommodate for cross-origin requests. Okay, so we've got all that set up. We can go ahead and save it. All right, next thing we want to do is turn on client authentication. I thought I already had that turned on, but whatever. Save. As we turn on client authentication, we should see an access token right over here. Sorry, a client secret, not an access token. That's the secret that Grafana is going to use in order to prove that it's a valid Keycloak client, as long as it can provide the secret that Keycloak is expecting. And its client ID is going to be Grafana. All right, we're almost done setting things up. So now, when we press that sign in button and our client Grafana gives the client secret, deeming this authentication request to be valid, we're going to be redirected to Keycloak's main page where it's going to expect user credentials. These user credentials, if Keycloak deems them to be valid, will be used to authenticate against our client, and thereby access tokens will be issued where they can actually access the application itself. So what we need to do is go to users. We're going to add a new user. I'm going to call the user Rayanne. You can call it whatever. Our slim ray@gmail.com. First name Rayanne, last name Slim. I'm just going to make sure I remember these. Create. Then go to credentials, set password. I'm just going to give Rayanne a password of password. Like so. Save password. Okay, so now, do we have enough? Let's find out. Let's first start by making a request in Postman. So go to your first post request where you can get an access token. So the access token basically authorizes our user to access the client. So the client is Grafana. All right, the client secret, we're just going to copy over. So remember, even though we're not actually using Grafana in this case to make this request, we still need to provide a correct client ID and secret so that the authentication request can be deemed valid by Keycloak. All right, the username was Rayanne. The password I set as password. And let's go ahead and make this request. Realm does not exist. Sorry, this should be Grafana. Account is not fully set up. Interesting. I'm glad we did this Postman request before doing anything else. Let me reset the password. This should not be temporary. Anyways, let's reset the password to password. All right, save it. Okay, we'll try this again. All right, so we were just given an access token that would effectively authorize the user, Rayan, to access the Grafana client. All right, so what would happen if we made that same request from over here? All right, so let's go ahead and do that. So localhost 3000. I'm going to go ahead, why is this so small, and sign in with Keycloak. Page not found. Oh, what we're going to have to do is rerun things because it's still making requests to test client. So let's stop that. So for Docker viewers, just put Docker Compose down and then rerun Docker Compose up. For my Kubernetes fellows, I'm not gonna Helm upgrade. Okay, we're good. We're gonna sign in with Keycloak. Beautiful. Client ID Grafana, you can see it right here. We were sent to some realm. I don't really see it, but hey, it's somewhere here. So now that the client has provided a valid client secret, now it's our turn to provide valid user credentials. So we'll go ahead and do that right now. Let me close these. Username I think was Rayan. Password I set to password. Sign in. And it redirects back to localhost 3000 at whatever path. And here we can see that we were effectively signed in using Keycloak. Signed in using my preferred username. So that's where all of this stuff comes in. Name attribute path, email attribute path. Those are all information that is provided. And you might be wondering, how does Grafana have access to all of this information? How did it retrieve this info from Keycloak? Well, you'll remember that it's connecting to this user info endpoint, and the access token that it's given also encodes a lot of information. The ID token it's given as well. We haven't really talked much about that. So we can go ahead and decode. Here, let me resend this. We can go ahead and decode this access token in order to see what kind of information Grafana is getting. So if we go to jwt.io, so this access token contains an expiry date. So if you decode this to something more user-friendly, 5 minutes from now, this bearer token won't be valid anymore. And here we can see things like name, given name, family name, etc. But the ID token is actually where it's able to verify the user's identity and what role they should have. So if we look at the ID token itself, again, this is what helps Grafana effectively verify who you are. The ID token is what it checks. And we are not really giving Grafana any interesting information here. So we're giving it the name, the family name, etc., but we're not telling Grafana what role this user should have within its service. So Grafana by default is just going to give them the viewer role, okay? So that's something that we need to encode within the ID token, what role each person should have. Because as you can see here, so this configuration is specific to Grafana. Something Kafka or Elasticsearch would have similar implementations. But essentially here, Grafana gets information from the ID token and it checks if there is a realm access role that equals the string admin, then it's going to give that user who logged in the built-in Grafana admin role. Otherwise, it's going to give it the viewer role that you just saw. So again, this user info endpoint is interesting. So if I go to user info and I paste in, let me get a new token. I think this one expired because I was talking too much. Let me get a new token, put it in the user info, put it here so that we can access this endpoint. Realm does not exist. This should be Grafana. So again, the user info also reflects what kind of information our client is going to get back about our user. Again, none of it really describes the role that they would have. So let's go ahead and encode that because I want myself, Rayan, to be given admin rights in Grafana. So now, inside of Keycloak, oh, did we lose it? I guess we did. All right, cool. Just make sure that you go back to the Grafana realm, not the master one. And so now we need to define how Keycloak adds specific user information like roles into tokens or user info responses so that when the client sees those tokens, knows how to properly identify the user and what roles to give them. So we'll define the client scope, the scope of information that they're going to see. Realm roles user info is what I'm going to call the client scope. We'll set this to default. Press save. Then go to mappers. Add a predefined mapper. And I'm going to say a user realm role, see what I get. We're going to add this mapper. And what this basically does is it ensures that whichever user is trying to sign into this client, it will include that user's realm level roles in the token or the user info so that the client has the info that it needs to give them its own proper built-in roles, okay? Without this, Keycloak won't include these roles by default. But now we need to bind this client scope to the client itself so that the client knows to want this information and so that Keycloak includes it in the token accordingly. So now we go to the Grafana client. We go to the client scopes and we want to give it the client scope we just created, realm roles user info. Make sure that's the default. All right, is it there? Let me just make sure. Indeed it is. And actually one thing I forgot to do before we test anything out, go to realm roles user info. Go to mappers, go here. I want to also add the information to the user info endpoint. All right, and now, oh, add to ID token as well. This is the most important step because the ID token is what Grafana is going to use to identify the user and whatever. So now let's press save. And get an access token. Now this same access token, which authorizes the user to access whatever client, in this case Grafana, can also be used to access the protected user info endpoint from Keycloak. So let's put that in there, press send, and now that user's role is included, the fact that they're an admin. Beautiful. And it's also included in the ID token that was given back, which is what Grafana is going to rely on in order to know who that person is. Perhaps it also uses the user info endpoint, who knows? Anyways, if you decode the ID token, we see the admin role. So now Grafana can effectively look at realm access.roles, check for admin. If it's there, it's going to map it to the built-in admin role that Grafana itself knows about, okay? And that's it, guys. We're done. Only one way to test this out is to do everything through Grafana itself, not through Postman, right? So now we know Grafana is going to get that information because it's going to be included in the ID token it gets back. So if I sign out, sign back in with Keycloak, is it actually going to read the admin role and know to assign them its built-in admin role? Indeed, it will. That's it, guys. I really hope you enjoyed this demo. Now it's time to clean up. All right, this is Rayan from Docker. I'm back. I hope you enjoyed the single sign-on tutorial and were able to take a lot from it. So let's go ahead and clean up before we finalize, because you don't want to have these things running in the background. First thing you want to do is make sure that you remove all stopped containers. So Docker compose down. You don't want them to still be there. Clear the output, then run docker system prune -a to remove any loose resources. All right, removing those. And before we leave, just so that we can finalize our cleanup, feel free to go to your Docker dashboard, which I'm going to open right now, and delete whatever volumes and stuff which were the result of your installation. So feel free to delete Keycloak Postgres data, delete that, delete whatever images still remain, and you should be good to go. I hope you enjoyed this lesson. If you did, please make sure that you subscribe to this channel to stay aware of any other DevOps content that we release. And if you find these guides helpful, make sure that you check out our Kubernetes training course. Link is inside the description. I'll see you in there.